Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at chemical families. And we are still continuing with different chemical families of the periodic table. Previously, we talked about the alkali metals and alkaline earth metals. So for today, we are starting on halogens. So we are going to do a bit of some introduction on halogens, and then we will do a few questions. So halogens are usually elements with 7 valence electrons. So they're usually in group 7 of the periodic table, and they're usually non-metallic in nature. This is contrary to what we saw with alkali metals and alkaline earth metals. So when you look at the members of the group, we have fluorine, chlorine, bromine, iodine, astatine, and yeah, and astatine. So you notice there's some similarities with the INE at the end. So they have 7 electrons in the outermost energy level. So you concentrate on fluorine, bromine, and chlorine and bromine, although bromine is beyond the 20 elements, and you can see how its electronic configuration is written. It's quite a bit different from what we use for the 20 elements. We're going to learn about this later on in campus, but we are also going to learn about bromine in this session. Not worry about the configuration. It's not going to be mentioned a lot, although it affects some of the properties of bromine. So you can see we are in group 7. So you notice we have skipped some group, as I said earlier. So we are not going to be looking at the details of this group 5, 6, and 7, 5, 3, 4, 5, and 6. But our concentration is on group 1, group 2, group 3, and group 4. So that's what you're going to be looking at. So the first thing we are going to look at is the graduation of properties of halogens. That means the atomic radius and the ionic radius. So the atomic radius, we defined it as the distance between the center of the nucleus of an atom and the outermost energy level occupied by electrons, while ionic radius is the distance between the center of the nucleus of an ion. So note it's an ion and the outermost energy level of the occupied electrons. So you'll notice this is going to be a bit different from the last two groups that we were talking about. So the ionic radius and atomic radius increases down the group. When we come to some other properties, you notice they are contrary to the alkaline and alkaline earth metal. So they usually increase down the group because there's an increase in the energy level down the group. So you notice the energy shells are increasing from fluorine to iodine, just like we saw in the previous slide. So next we look at the atomic and ionic radius of the same element. So this is going to be quite a little bit different from the previous chemical families we have been talking about. So the ionic radius in this case is the one that is larger than the atomic radius. So let's see why that is so. So when you look at, for example, fluorine, which is 2.7, and when you look at this fluorine, it reacts by gaining an electron, so it becomes 2.8. You can see we do not have more energy shells, but the ion is going to be larger than the atom. Why? The reason why it is larger is because ions are usually formed by gaining an electron, and this electron is being added in a group of other electrons. And you know from physics that like poles repel. So there's a negative charged electron is being added to another group of negatively charged electron. So what happens is something we call electron-electron repulsion. So this electron repulsion causes the ion to bulge. So it looks and it becomes bigger because the electrons are avoiding each other. Hence, that's why we have decreasing in the nuclear attraction of the outermost electrons in the outward nucleus. So just a representation, for example, fluorine, we said we have 2 electrons in the first shell. In the third shell, we have 7 electrons. So we are adding an electron already in a shell containing electron. So those negatives and negatives, they usually repel each other. So that is the reason why we have that bulge. There's a bulge that occurs. So the ionic radius is bigger than a normal atomic radius. So you can see the configuration is increasing down the group as we had discussed. The atomic radius is also increasing down the group as we had discussed. The ionic radius is increasing down the group as we had discussed. If you look across, you notice the ionic radius is larger than the atomic radius, as well as in chlorine, in bromine, and also in iodine. You can see the ionic radius is larger. So next, let's look at a few questions. So explain the trend of the atomic radius of the halogens. So we said the atomic radius increases down the group. Why there is an increase in the energy levels or energy shells down the group. And then the next question is, using dots and crosses, explain why the ionic radius of chlorine is larger than its atomic radius. So it tells us we show. So we are going to show the atom. Chlorine is 2.8.7. So the atom is 2.8.7. The ion is 2.8.8 because it gets 1 electron. So the ion it has 3 shells. The second shell and the third shell. So that's how the chlorine atom looks like. So we put the first 2 electrons in the first shell. We put the 8 the first 2 shells in the first shell the first 2 electrons in the first shell, the second 2 electrons in the second shell. So the second shell, remember, it has 8 electrons, and the last shell has 7 electrons, as you can see. And then for the ion, it's going to be chlorine. So it has 3 shells as well. And remember, we said the ion must be enclosed. So the first shell has 2 electrons, the second has 8 electrons. I'm going to use dots in this case, although the crosses would have been better to show the difference in electrons, but it's still okay. I'm still going to show you that difference. So you put an X to show that it has gained 1 electron. So we said that the ionic radius is larger because an atom gains an electron, which causes electron repulsion, thus causing the ion to bulge, causing it to be bigger. So the idea is to show the electron that is being added in a group of electrons. So there is that electron repulsion that occurs. between that one electron and the existing electrons. So the ion will budge on the outwardly, causing it to be bigger or larger than the atom. So that brings us to the end of the subtopic. It was short, but in the next lesson, we are going to discuss some of the physical properties of halogens. So see you then.